Now that you understand how three-way switches work and how to wire them correctly, let's introduce you to four-way switches. Four-way switches enable you to turn on lights or other devices from 3 or more different locations in your home. At first glance, when you compare these two switches, you'll see that a four-way switch has one more terminal than the three-way switch we just discussed. In fact, a four-way switch looks very similar to a regular double-pole switch. They both have 4 terminal posts on their sides. However, don't confuse the two. A double-pole switch is used with 240-volt current and has the words on and off clearly displayed on the switch. You will never see any on and off wording on the face of a four-way switch. On the back of a four-way switch, notice that the 4 main terminal posts are divided into 2 matched pairs. Here, you see a pair of black screws and a pair of brass screws. There is also a green hexagonal screw that serves as the switch's ground terminal. Four-way switch designs vary depending on their type and the manufacturer of the switch. They may look different, but they all still have 2 sets of matching terminals. Each has a pair of black terminals, and each has a pair of brass terminals. No matter what type of four-way switch you're using, just remember to distinguish between these 2 pairs of terminal screws when you begin to wire these switches. A four-way switch is a device that does nothing more than simply redirect the flow of electricity from one terminal to another. We'll see exactly how this is done in a moment. If you understand how a three-way switch scenario works, a four-way switch setup should be easy to learn. Remember what we've just seen. A three-way switch setup has 2 three-way switches controlling a light or other device on a circuit. To enable this light to be controlled by 3 or more switches, you simply add a four-way switch onto the circuit at a position somewhere between the 2 three-way switches. Four-way switches are always installed between 2 three-way switches. You may add as many four-way switches to the circuit as you want to meet your wiring needs, but they all must be positioned somewhere in line between your 2 three-way switches. But we will demonstrate this four-way switch scenario using one four-way switch positioned between 2 three-way switches. For more information about wiring other four-way switch variations, we recommend you refer to a self-help manual and contact a professional electrician. Now, taking a look at this four-way switch example, we see that the incoming cable arriving to the first three-way switch is a regular 2-conductor cable like we used in our three-way switch example. Again, this cable has 2 conductors, black and white, and 1 ground wire. The cables leading to and leading away from the four-way switch are both 3-conductor cables, having a black, red, white, and ground wire. And the cable leading away from the last three-way switch to the light at the end of run is another 2-conductor cable with a black, white, and bare copper wire. You wire this scenario beginning in the same way we demonstrated with the three-way switch example. You attach the black wire from the incoming power cable to the common screw on the first three-way switch. And as we saw before, we connect the black and red traveler wires from the 3-conductor cable leading to the four-way switch to the three-way switch's traveler screws. We know that incoming electricity will arrive here and attempt to pass through this three-way switch and continue on to the new four-way switch via one of the traveler wires. Now let's take a moment to analyze how current will pass through a typical four-way switch. We can do this using a continuity tester. In this demonstration, we see that when the switch is in the down position, the continuity tester will light up. This means that this switch has an open path that allows current to pass between the upper left black terminal and the lower left brass terminal. At the same time, on the other side of the switch, we see that current can also pass between the upper right black terminal and the lower right brass terminal. When we put the switch in the up position, the switch crisscrosses the current's flow. Now the switch is allowing current to flow between the upper left black terminal and the lower right brass terminal. And, at the same time, Current can pass from the upper right black terminal and the lower left brass terminal. On a four-way switch, current will never flow from one black terminal to the other black terminal, or from one brass terminal to the other brass terminal. Now that we can see how our four-way switch works, let's continue where we left off. On our four-way switch, we'll first locate the traveler wires coming from the first three-way switch and connect them to a matched colored pair of terminal screws. It doesn't matter which of these two traveler wires you connect to either terminal. A four-way switch will work for you no matter which terminal you choose on this pair. What's most important to remember is to never attach one traveler wire to a brass screw and the other to a black screw. If you do this, the four-way switch won't function properly. On the back of this switch, you may see that the manufacturer advises where to attach your traveler wires. We will follow their instructions. On the backs of other four-way switches, you may also find similar wording. Often you'll see guides, such as ins and outs, clearly displayed on the switch. You'll notice that the pairs will match. Some manufacturers may not indicate which pair of terminals to use for the incoming current, in which case you may choose for yourself. Always pay attention to the colored pairs you are using. Now connect the black and red outgoing traveler wires from the cable leading to the second three-way switch to the brass pair of terminal screws. Again, it doesn't matter which colored traveler wire you connect to either one of these brass terminals. Moving to the second three-way switch, we will connect the incoming traveler wires from the four-way switch to the traveler screws on this switch, just as we did before in our three-way switch demonstration. Then connect the black wire belonging to the outgoing two-conductor cable to the common screw. Now let's see how this four-way switch setup will function when electricity is flowing through the circuit. Incoming current will arrive first at the first three-way switch's common terminal. With the switch in the down position, the current will pass through to the left traveler terminal and travel along the black traveler wire until it reaches our four-way switch. Here, with the switch in the down position, the current will pass down through the switch and continue along this black traveler wire until it reaches the second three-way switch. Once the current arrives here, it will pass through to the three-way switch's common screw if the switch is in the down position. In this case, the current has an unobstructed path through the circuit to reach and illuminate the light. Let's back out so we can see this path clearly. The benefit of a four-way switch setup is that at any switch along this path, you will be able to turn off or turn on the light. Notice how the path of the current is affected as we turn off and turn on the flow of current. A complete circuit is broken or created every time there is a flip of the switch. Now let's finish this installation by combining the neutral wires together with a wire connector at both of the three-way switch locations. Do the same with the neutral wires at the four-way switch. Also connect your ground wires in the same fashion. Join them together with wire nuts and use pigtails to connect them to the switch's ground screws and metal boxes at every switch location. As a precaution, please consult with a licensed professional electrician before attempting any complicated electrical project.